Alright, and in this example we're going to talk about spheres again. We're going to do an example where a spherical ball is floating on a lake and then the lake froze. Okay, and then when the ball was removed, what happened was that there was a 24 centimeter hole across that was also 8 centimeters deep. So our goal here is to find the radius of the ball. So the idea, the sketch here is, okay, we have the surface of the lake, we assume it's flat, we assume that the water flows in a flat manner, and then there's a little divot here. Okay, and then the lake continues. So what happened was that, I'm going to move this down just a little bit. Okay, and then we have the ball was sitting here in this divot, and then the ball was removed. Okay, so again, forgive my drawing, but the idea should be clear enough here. So this distance, and I'll maybe do it in blue here, this distance here was 24, and the depth here, the total depth, was 8 centimeters. Okay, so maybe I'll move this out here and this. Nope, that's going to stay there, I guess. Okay, so then this distance, the vertical distance here is 8. So what I'm thinking is that it would be really nice if we could use the radius of the sphere somehow, or find, so the objective here is to determine the radius of the ball. Okay, to do that, I think I would suggest that you pause the video and attempt this on your own. Okay, what I'm thinking is that I'm going to try to use triangles. Alright, so what I know is that from this point to this point, I know that distance is 24. So if I identify a line from those points to the center of the ball, that would be our radius, right? Okay, well that's easy enough. And I also would know that the total distance here from the center to the very bottom here, that would be a distance of r as well. Okay, but now what I'm going to do is I'm going to pull this out into a slightly bigger diagram. Okay, so I have, here's the center, and each of these are a radius. Okay, and that would be r2. And now I know that this down here is 8, and if I know that this whole distance is r, this distance in here would have to be r minus 8. Okay, and then, okay, so this is all fine and dandy, but where are we going? Well, this, I claim that, well, this is a radius, and the surface level would have to intersect at a right angle. Okay, and with that in mind, I could then use the Pythagorean Theorem, because so essentially what I did was I formed the angle bisector, okay, of this angle, whatever it might be. And that angle bisector actually ended up being a perpendicular bisector as well. So this ends up being 12, a distance of 12 over here, and so then with that I can make my Pythagorean theorem. R squared is equal to the quantity r minus 8 squared plus 12 squared, and going ahead and simplifying this is r squared is equal to r squared minus 16r plus 64 plus 144. Okay, and then I go ahead and simplify this some more. 16r is equal to 208. And so r is going to be 13 centimeters. So this tells us that the ball was 13 centimeters long, or the radius of the centimeter, or the radius of the ball was 13 centimeters. So again, why did I do this? So I saw that the divot, I don't say divot, but the portion of the indentation in the lake was 24 centimeters across. Okay, now if it's reasonable to assume that with this divot, okay, the divot was 8 centimeters in the ground, or 8 centimeters into the lake, that that the ball sat up a distance, so the radius of the ball would not be 12. So instead, what I did here is I assumed that okay, well, if I found the intersection of the sphere with the lake, and that was at these 2 points, and that distance from the center of the ball was r units. Okay, and now with that in mind, what I said was that, okay, well, if this is 24 centimeters across, I'm going to construct this other point from the center of the ball to the very, very bottom of the divot. So I know that the distance below this line where it would meet the lake, or where the lake would be, is 8 centimeters. And then the other distance here would have to be the other part that adds up to a total distance of r. So that was r minus 8. Okay, and then with that, I was able to construct a right triangle and use the Pythagorean theorem to determine the radius of the ball.